Hello, my name is Matthew Wilson, and this is our intro to multiplexers, or muxes for short. First question today is, what is a multiplexer? Also known as a data selector as well. It's the process of many lines coming in, but only one piece of data is selected. So in other words, the line that's been selected has its signal transmitted, whilst the other one is blocked off. So as you can see, this example from the slide shows nicely kind of what I mean by that. So you have your two data inputs here, your selector here, and your output here. And a nice little trick is to think of this gate right here. It kind of funnels in. You see it takes like the two inputs here and here and kind of pushes its way down into one output, and that's done through the use of the selector tool. And there's different kinds of multiplexers. There's 2x1, 4x1, and an 8x1. And the amount of lines and data lines you have depends on the simple logic. With n data lines, you can have up to 2 to the power of n data input lines. So for example, if you have one data select, you're going to have two inputs. Two data select, you're going to have four inputs. Three data selects, you're going to have eight inputs. Four data selects, you'd have 16, and so forth. And that brings us to our logism, where I'll be going over the 2x1, 4x1, and 8x1 multiplexers. Okay, so over here in Logisim, we have our 2x1 multiplexer, which basically is pretty simple. It just features some and or logic that we're pretty familiar with already. And to go ahead and showcase how this works, so we have our two data inputs, D0 and D1, and our selector input here. So let's say, for example, I want to do input 1. As you can see, it has a straight pass-through. This is with our selector tool at 0. So in other words, it's selecting D0 as our input to go through. But if I wanted to go ahead and shut that off, I could go ahead and flip this switch on, which is going to go ahead and block this one from going anywhere but the use of the not symbol, and instead focusing on our D1 here. And the same way around, if I went ahead and unselected these, selected D1, as you can see, right now it's reading our D0, which has an input of 0, because the selector is off. But if we go ahead and select D1, then it's going to go ahead and give power to this one here, and it's going to input our output, our 1 result there. This little simple design will prove useful for our next topic, which is our 4x1 multiplexer, seeing as we just kind of combined two of these together. Moving on to our 4x1 multiplexer here, a little more complex, but it pretty much serves the same function, just doubled, you could think of it as. So as you can see here, we have our C0, C1, C2, and C3. So these are basically just going to function exactly like how I did in last example, but it's just going to add an extra layer as well. So this first select tool is actually going to work for both of our 2x1 multiplexers here. Then we're going to have a second switch for our last multiplexer here. So the way this is going to work is, if we think of it like our first 2x1 here, if we went ahead and selected this first C0, as you can see, it has a straight pass through, as it should. And like we stated previously, if we turn on this first switch here, it's going to go ahead and cut off this power here and go ahead and give leeway to our C1 value. And same thing for the C2. Cuts off power again. And the roles vice versa as well. C3 is going to give direct power through and cut off C2. And same thing with C1 as well. It's going to cut off that power and then go ahead from C0 and give direct access to C1 there. But as you noticed, going back to our C3 being on here, it actually does not give direct leeway. As you can see, it's being stopped over here at our third 2x1 multiplexer. And this can be changed through our next selecting switch. So essentially what we did here is took the outputs of both of these 2x1 multiplexers and put them into another 2x1 multiplexer. which is going to serve the exact same purpose again as our 2x1 multiplexer. So if we have 1 going into here and we select 1, then it's going to go ahead and block off that 0 there and give direct access to our final output. And to go ahead and show you guys that on the opposite side of that, if we go ahead and highlight our C0 with our switch 0 off here, as you see, it's going to give direct access. It's going to funnel down into here, and it's going to give us a straight output of 1 because our selector is off here, meaning it's blocking off our 1 value and giving direct access to our 0 value there. And if we went ahead and turned this on, it would block off this top value here as 0 and pass through the 1, giving us an output of 0. And this 4x1 multiplexer will give us another building block, another foundation for our 8x1 multiplexer, which I will showcase now. And now we have our 8x1 multiplexer. And this may look a little confusing at first, but a common theme you guys may notice is that these serve as building blocks on top of each other. So, starting from our 2x1 multiplexer, we were able to build our 4x1 multiplexer through the use of 3 2x1 multiplexers, and then we built our 8x1 multiplexer through the use of 2 4 multiplexers and 1 2x1 multiplexer. You can see that here, but these are our 4x1 multiplexers, and then our 2x1 multiplexer here, which is used to combine the two outputs of our 4x1s and give us our output. So we can go ahead and test this circuit just as normal. So if we went ahead and thought of it as our normal 4x1 that I just showed previously, if we went and selected these two, we would know that these C0 and C2 are going to have a direct pass through to our 2x1 multiplexer. And if we went C5 and C7 here, as you can see, it's going to be blocked off. And now these can change and vary based on our selector here. So if we wanted to go ahead and select our 0, we leave it at 0, giving it that straight pass through. Or to turn this on, we block out this first 0 here and give leeway to our 1 value here. Then this is where we'll go ahead and make use of our selector tool. So as you can see here, we're on selector 0. We selected 0, sorry. If we want to turn this on, to go ahead and get rid of this block that we have at 1, give it a straight pass through and give us our output of 1. And as I stated previously in our slideshow, as you can see here, we have 8 inputs, meaning we're going to have 3 select tools. And that is all I have for 2 through 8x1 multiplexers. The last thing I have to show you guys today is our 4-bit 2x1 multiplexer. Basically, the functionality of this multiplexer is to highlight 2 given inputs in binary, and you're able to choose which inputs you want to be outputted. And this basically serves the same purpose as our previous multiplexers, because through the use of our 4 2x1 multiplexers here. And this selecting switch will go ahead and decide through the use of these 2x1 multiplexers here which input values to be selected. So over here, I set up a nice and simple little testing station to test this. So A3 being our most significant bit here, if we wanted to test the values of 1011 or 0010. As you can see here, you can see the use of our 2x1 multiplexer in here already. Our first A values here are just a direct pass through because our selector tool is off. And another way you can think about this is A or B prime, kind of selecting which ones need to be powered on and which ones need to be powered off instead of using just a letter like S. This kind of gives a more clear visual of what's being selected and what's being highlighted. So right now when this is off, it's giving direct pass-through through A. And when I turn this on, we're going to be looking at our B values here, which is going to go ahead and output our 0010. And we can switch between the two, 1011 when it's off, when it's on, 0010. And that is all I have. Thank you.